Okay, so in this video, we're going to solve the trig equation 2 sine of x minus cosecant of x equals -1. And we want to find the angles over the interval 0 to 2 pi inclusive. So we're going to be working in radians as opposed to degrees. And the first thing you want to do when you're trying to solve a trig equation that has two different trig functions in it is see if you can use an identity to convert it all to the same trig function. So if I take a look at this cosecant, cosecant is the reciprocal of sine. It has that diagonal relationship in the trig hexagon. So I'm going to rewrite this as 2 sine of x minus 1 divided by sine of x using that reciprocal identity, and then that's equal to -1. Okay, next going to need a common denominator to be able to combine these. So I'm going to go ahead and make this a sine squared in the numerator and a sine x in the denominator by multiplying the top and bottom by sine of x over sine of x. I don't change its value. It just allows me to have a common denominator to combine these two fractions. So now that the denominators match, I can subtract across the top. So I'll have a 2 sine squared x minus 1, all divided by sine of x is equal to -1. And whenever you see a square, you're usually reminded of Pythagorean identities, and you start looking for ways to swap things out again. But remember our goal. Our goal was to get everything in the same trig function, and we've accomplished that. We have just signs now in our equation. So rather than trying to swap out things with a Pythagorean identity, at this point we just want to try to solve for x. So if I multiply both sides by the sine of x. Now on this side they cancel, and I'll have 2 sine squared x minus 1 is equal to -1 times sine of x is negative sine of x. Okay, and now I want to get everything equal to 0 so that I can factor it. So I'm going to add over sine of x to both sides, and I'll have 2 sine squared x plus sine x minus 1 equals 0. Now, if you have a hard time looking at this and seeing how to factor it, which a lot of students will, you can just pick another letter and substitute that for your sine of x. So I'm going to say, let's pick a letter W, right? So W is equal to the sine of x. Now I can rewrite this expression to W squared plus W minus 1. That's what I'm trying to factor, right? 2 sine squared x plus sine x minus 1. If sine of x is W, I'm just changing out this sine squared x for a W squared and this sine x for a W, and then my minus 1. And that helps me see how to factor this a little easier using a crisscross and a box. Now, if you can factor it faster another method, absolutely do that. This is just for people who need a little bit more support with their factoring. So we multiply the first term and the last term. So 2w squared times -1 is -2w squared. That goes in the top of the crisscross. The middle term, the linear term, goes in the bottom of the crisscross. And then we ask ourselves, what are the factors of -2w squared that add to equal a positive w? And that would be 2w and -w. Because if I multiply them, I get the top, and if I add them, I get the bottom. So these two factors will go into the box, including their signs, just like this, and they're interchangeable. You could put them in either of those boxes. Now, to fill out the rest of the factor box, the first term goes in the first box, so 2w squared. The last term, the constant, goes in the last box. That's -1. And then we go across each row, up and down each column, looking for the GCF. So 2w squared and 2w have a GCF of 2w. Negative w and -1 have a GCF of -1. Then 2w squared and -w have a w in common. 2w and -1 have a 1. So these are going to be, along the outsides here, my factors. So this expression factors as 2w minus 1 times the quantity w plus 1. And now that it's factored, we can go ahead and replace all those w's with the sign of x, right? We only did that substitution just to make it a little easier to look at. So now I'll have a 2 sine x minus 1 because I just replaced w in that factor with sine of x. Now I'll do the same thing with this second factor. I'll replace the w with sine of x, and I have sine of x plus 1 equals 0. And now that my equation is completely factored, I can use the zero product property to set each factor equal to 0. So 2 sine of x minus 1 equals 0, and sine of x plus 1 equals 0. Those would be my two equations that I want to solve. So on this side, have sine of x is equal to 1/2, and so x is the arcsine of positive 1/2. On this side, I'll have sine of x equals -1, and x is equal to the arcsine of -1. So just to get some more room here so that we can see what our answers are going to be, I'm just going to journey our way up here. And for this first equation, arcsine of positive 1/2. So if you take a look at your unit circle and you want to find whatever angle has a y-coordinate of a positive 1/2. And for the first quadrant answer, that's going to be pi/6. But if you recall, all students take calculus. Sine is also positive in quadrant 2. And so 5 pi/6 is also going to be a solution. Okay, then our second equation, we have that x is equal to the arcsine of -1, and that's asking us to find the angle on the unit circle that has a y-coordinate of -1, and that is true only at 3 pi/2. So that would be just 1, 2, 3 possible solutions that we want to consider for this trig equation. So we're going to use the graphing calculator next to check and see if those answers work or if they are extraneous. So first thing we want to do is go to the mode, make sure that we're in radian mode, which we are. Then we're going to store pi/6 as the x and press enter. And then we're going to type in this original equation just like we see it. So 2 sine of x and then minus. But when we get to the cosecant of x, notice there's no cosecant button on the calculator. So we're going to need to use a reciprocal identity on the cosecant. So alpha y equals number 1 gets our fraction template, and then 1 over sine of x, since the reciprocal of cosecant is sine. Then second math opens up the test menu, and number 1 is the equals, and then the other side of the equals is a -1. Remember, whenever we use the equal sign in the graphing calculator, we're asking a yes or no question. So when the calculator substitutes pi over 6 everywhere there's an x, if it's a true statement, it's a yes, it'll respond with a 1. If it's false, it'll say 0 for no, and we get a 1. So pi over 6 works. Next, we're going to check 5 pi over 6 and store that as x. And then you can arrow back up to your equation and press enter. And we also get a 1, so 5 pi over 6 checks as well. And then last but not least, we're going to check 3 pi over 2 by storing that as x. Arrow up, grab that equation, press enter, and 3 pi over 2 also checks. Okay, make sure you always check your solutions though, because as we've seen in some of the other videos, sometimes those answers are extraneous. They're outside of the domain, and so you have to exclude them from your solution set. But in this case, all of them worked.